Hi, my dear students. Welcome to ME Educational Institutions. Today, we are going to solve some problems based on mechanical properties of solids. In this session, we can discuss determination of maximum angular velocity of the body, which is in horizontal circular motion. Let's start the session. Read the question carefully. A wire of length 0.3 meter and area of cross section 10 power minus 2 centimeter square and breaking stress is given as 4.8 into 10 to the power of 7 Newton per meter square is attached with the block of mass 10 kg. If the maximum possible value of angular velocity with which block can move in a circle with a string fixed at one end is dash radians per second. Option A, 1 radians per second, 2 radians per second, 3 radians per second and 4 radians per second. First, write down the given data. Here we need to discuss maximum angular velocity of the block. Here parameters, what are the different parameters? See here, length of the wire is given as 0.3 meter. This would be length of the wire is given 0.3 meter. After that, area of cross section of the wire 10 power minus 2 centimeter square. After that, breaking stress, sigma breaking stress or stress at failure point. It is the maximum stress up to which material can withstand the loads without occurring any failure. 4.8 into 10 to the power of 7 Newton per meter square. A block of mass m, 10 kg of block of mass m is attached. Then, and one more thing is given here, it is moved in a circle. Okay, na? So, entire part angular velocity with which block can move in a circle with the string fixed at one end. Understood na? So here we need to discuss procedure to determine omega maximum. Just observe maximum angular velocity of the block. See this here, R equal to L, maximum angular velocity condition, R equal to L. Here I have taken circular. Okay, block is in circular cross section. This is the circular block. I am assuming it. Nothing wrong in that. Mass of the block is given as 10 kg. See here, everything. Now we can draw free body diagram for the block. Weight of the block always act vertically downward direction. Centrifugal forces always act away from the center of circular path, center of circular motion. Here it is how much? Omega maximum, maximum angular velocity condition. In that case, FC maximum, maximum centrifugal force, and tension in the string, tension in the, this is the tension in the wire. Okay, tension always pull the body. This tension pulling the body. This is what here the theta will be. Here I can say that here I am taking theta equal to 90 degrees or else it is moving, it is making an angle with vertical in anti-clockwise direction. It is correct. Understood na? So theta equal to 90 degrees maximum angular velocity condition. Okay, so now we can try to solve this problem. Draw the free body diagram. See this, we already done this part in the theory, and maximum angular velocity of the block condition. Here you can take sigma h equivalents to 0. Sigma h equivalents to 0. Understood na? Centrifugal forces acting away from the center of the circular path. This would be maximum angular velocity. Sum of the left force equal to sum of the right forces. This would be tension equal to maximum centrifugal forces FC maximum. Here I can say that T equal to MR, omega maximum square. Here R equal to L. You can write it as at maximum angular velocity condition, radius R equal to L. Okay, na? So now I can write T equal to M L omega maximum square. So they are asking omega maximum angular velocity of the block, square root of T by ml. Omega maximum equal to T by ml, maximum angular velocity of the block. I can say that this would be maximum angular velocity of the block. Angular velocity of the block. T would be tension in the string. Maximum angular velocity of the block. I can say maximum tension only. Maximum tension in the string. This would be maximum. T maximum. You can write it. Nothing wrong in that. T maximum. Here it would be T maximum. Maximum tension in the string. At maximum angular velocity condition, this would be maximum tension in the string. Maximum tension in the string. Okay, this is the maximum tension in the string for corresponding omega maximum. Now we can see this here. Given data, these are the parameters given in the question. They are asking maximum angular velocity. So what is the breaking stress? Tell me, what is the breaking stress? Length of the wire. Length of the wire and area of cross section is A. Length of the wire and area of cross section is A. What is given? Breaking stress. Sigma breaking stress. Breaking stress. We already know that. Okay, so what is the load acting? Load acting, maximum tension. This is the maximum tension. Okay, maximum tension is induced. Okay, by area of cross section. From here you will be getting area of cross section, sigma breaking. So now tell me how much you will be getting. What is the breaking stress? 4.8 into 10 power 7 Newton per meter square equivalents to what is T maximum in this case? What is T maximum? MR omega maximum square. So at this particular condition, R becomes equal to L. I can write it as ML omega maximum square. This would be ML omega maximum square by area of cross section. We can substitute mass of the block is nothing but 10 kg. M would be mass of the block. L would be length of the wire, 0.3 meter. They are asking omega maximum angular velocity by area of cross section, 10 power minus 2. This would be centimeter square. In terms of meter square, we need to substitute this 10 power minus 2 whole square, 10 power minus 4. This would be meter square. Area equal to 10 power minus 2 centimeter square equal to 10 power minus 2. Here 10 power minus 2 meter whole square equal to 10 power minus 6 meter square. Here 10 power minus 6. You can take it to the left hand side. Then what people are getting? What people are getting? This part. 4.8 into 10 power 7 into 10 power minus 6. Okay, meter square gets cancelled out. Here it would be Newton. Here how much you are getting? 10 into 3. Here it would be 3 omega maximum square. Omega maximum square. Finally, how much you are getting? 4.8 into 10 you will be getting 48 by 3. Omega maximum square equal to 16. Omega maximum equal to square root of 16 equal to 4 radians per second. What is the final answer to this question? 4 radians per second. I can say that this would be the answer. 4 radians per second. Understood na? We already done. This is the breaking stress is given. We substituted all the values. We have done reasonable calculations. Finally, we got omega maximum equal to 4 radians per second. Here, this is the data. And finally, maximum angular velocity. This is 4 radians per second. What is the final answer to this question? Omega maximum equal to 4 radians per second. This is the way to solve this problem. We have drawn free body diagram for the body, then applied D'Alembert's principle in order to get the expression for maximum tension induced in the string at maximum angular velocity condition. Then we have taken the definition of breaking stress. After that, you substituted complete given data. Then we calculated maximum angular velocity of the body. This is the way to solve this problem. Read the question carefully. A metal wire of length 0.3 meter and cross-sectional area 10 power minus 4 meter square has breaking stress 5 into 10 power 8 Newton per meter square. A block of mass M is 10 kg is attached at one end of the string and it is rotating in a horizontal circle. The maximum linear velocity of the block will be dash meter per second. It is very simple to calculate. They are asking maximum linear velocity of the block. This question given in JEE Mains 2022 shift 2. Write down the given data. Length of the wire is given as 0.3 meter. Area of cross section 10 power minus 4 meter square. Breaking stress 5 into 10 power 8 Newton per meter square. And mass of the block 10 kg. And they are asking maximum linear velocity. So here we need to take maximum angular velocity condition, that is a maximum linear velocity. Here we will be drawing, this is the hinge and horizontal circular motion. The body is in, the block is in horizontal circular motion. Maximum angular velocity condition, horizontal circular motion. Weight of the block always act vertically downward direction. Centrifugal forces always act away from the center of rotation of the circular path. center of rotation of the body. This is the center of rotation of the circular motion. Center of rotation of the circular motion of the body. Center of rotation of the circular motion. Centrifugal force away from the center of rotation. FC maximum, they have this is the FC maximum away from the center of rotation. Tension in the string, this would be tension in the string, tension in the wire, tension in the wire. Okay, so angle 90 degrees, maximum angular velocity condition, and R becomes equal to L. Here R equal to L. I can confidently say that R equal to L. R equal to L. Now see this, you can try to solve this problem. Try to draw free body diagram for the block, weight acting downward direction. In this case, there is no effect of gravity. FC maximum, and this is omega maximum. Here I can say that omega maximum. This would be T maximum, maximum tension in the string. Here it would be maximum angular velocity. Here we need to apply D'Alembert's principle. Now we need to apply D'Alembert's principle at maximum angular velocity condition. We already know that D'Alembert's principle is used to convert dynamic problem into static problem. Here we represented centrifugal forces acting away from the centripetal acceleration. So dynamic problem converted into static problem. We represented centrifugal forces in the free body diagram. Okay, dynamic problem converted into static problem. Here you can directly write static equilibrium equation. Sigma H equals to 0. Sigma H equals to 0. Sum of the left force equal to sum of the right forces. Maximum tension induced in the wire, that is at maximum angular velocity condition. This would be maximum angular velocity, MR, omega maximum whole square. Here we know that what is the maximum linear velocity, equal to R omega maximum. Here you can write T maximum equal to how much? T maximum equal to M R omega maximum square. You can multiply and divide with R. You can multiply and divide with R. You can write it as M R omega maximum square by R you will be getting. Finally, we can write T maximum tension in the string, tension in the wire, M V maximum square by R you will be getting. We already know that maximum centrifugal forces, maximum centrifugal force, V maximum square by R. Here R becomes equal to L. R becomes equal to L at maximum angular velocity condition. So now we can try to solve this problem. Here given data is this. So length of the wire, maximum angular velocity condition, area of cross section A, and everything given. So take the definition of breaking stress. What is the definition of breaking stress? Sigma breaking stress, sigma B equal to breaking. This is the breaking stress. Sigma breaking stress. T maximum by maximum load acting on the wire. It is tensile in nature. T maximum by area of cross section of the wire. Area of cross section of the wire. I can say that T maximum is nothing but T maximum by area of cross section. T maximum is nothing but, here I can say, what is T maximum? M V maximum square by R. R equivalents to L. That is why we can write M V maximum square. V maximum square by L and A. This is the area of cross section A. Sigma breaking stress, how much is given? 5 into 10 to the power of 8 Newton per meter square. Here it is how much? Mass of the block 10 kg is given. We need to calculate maximum linear velocity of the block. Maximum linear velocity square, length of the wire 0.5 meter into 10 power minus 4 meter square. 10 power minus 4 meter square. Then what do people are getting? Tell me. Here you can take this part to the left hand side. Then 5 into 10 to the power of 8 meter square gets cancelled out into 0.5 into 10 power minus 4. This would be Newton equal to 10 times V maximum square. V maximum square. So then how much is this? 10 power 4, 10 cube. 25 into 10 cube by 10. Okay. So this would be V maximum square. V maximum square. Finally, what is V maximum? V maximum equals to square root of 25 into 10 square. 25 into 10 square meter per second whole square. Finally, V maximum equal to 5 and 10, 50 meter per second. That is the final answer to this question. 50 meter per second. Understood? So this is the way to solve this problem. What is the answer to this question? Finally, 50 meter per second. What is the final answer to this question? Maximum linear velocity equal to 50 meter per second. Understood? Read the question carefully. The body of mass 5 kg is attached to the wire of length 0.2 meter long. Its breaking strength is 5 into 10 power 7 Newton per meter square. Can be rotated in a horizontal circle with maximum angular velocity 5 radians per second. Then the area of cross section of the wire is dash meter square. 5 into 10 power minus 5 meter square, 5 into 10 power minus 6 meter square, 5 into 10 power minus 7 meter square, 5 into 10 power minus 8 meter square. They are asking area of cross section of the wire in terms of meter square. Try to write down the given data. See here, what is given? Mass of the block, mass of the body is given as 5 kg and length of the wire is given as 0.2 meter. Breaking stress induced in the wire 5 into 10 power 7 Newton per meter square. Angular velocity of the body when it is in horizontal circular motion, 5 into radians per second is given. They are asking you to determine area of cross section of the wire. What is the question asked in this? What is the area of cross section of the wire? Dash meter square. That is the question. Try to solve this problem. Area of cross section of the wire, and it is in circular motion, horizontal circular motion. Weight always act vertically downward direction. Centrifugal force always act away from the center of rotation of the circular path. Tension always pull the body. This is the maximum tension induced in the wire. Maximum centrifugal forces at maximum angular velocity condition, theta equal to 90 degrees. And here R becomes equal to L. Maximum angular velocity condition, R becomes equal to L. Horizontal circular motion. This would be horizontal circular motion of the body. Circular motion of the body. Horizontal circular motion of the body at maximum angular velocity condition. See the free body diagram. Here weight acting downward direction, maximum tension. This would be maximum tension, FC maximum. Here it is maximum. There is no effect of gravity. G equal to 0. No effect of gravity. In order to move in this manner, no effect of gravity. Now, see this free body diagram, we can apply D'Alembert's principle. R equal to L. Here is R equal to L. So, centrifugal forces represented in the free body diagram. That means dynamic problem converted into static problem. Straight away apply static equilibrium equations. Sigma H equals to 0. Sum of the left force equal to sum of the right forces. Maximum tension induced in the wire equal to maximum centrifugal forces. This is the maximum centrifugal forces. T maximum equals to M times R omega maximum square. Here R equal to L at maximum angular velocity condition. What is the T maximum? You can write M times L omega maximum square. M times L omega maximum square. What is the T maximum? M times L omega maximum square. See here, write down the given data. We can easily calculate length of the mass of the body. Okay, 5 kg and breaking stress, everything given. Length of the wire at maximum angular velocity condition, R equal to L. Area of cross section A. Now, what is the breaking stress? Sigma breaking stress. This would be breaking stress induced. This is the breaking stress. Maximum stress up to which material can withstand the loads without occurring any failure. T maximum by area of cross section of the wire. They are asking you to determine area of cross section of the wire. They are asking you to determine A only. What is the T maximum? M L omega maximum square. by area of cross section. This is the sigma breaking stress. Sigma breaking stress. Okay. Now write down the given data. 5 into 10 power 7 Newton per meter square. Mass of the body is nothing but 5 kg. This would be 5 kg. What is the length of the wire? 0.2 meter. 0.2 meter. 0.2 meter. What is the maximum angular velocity? 5 radians per second whole square. 5 radians per second whole square by area. So now what is the area of cross section of the wire? What is the area of cross section of the wire? Here 5 into 0.2, 1 you will be getting. Here it is 25 by 5 into 10 power 7. So entire part you will be getting in terms of meter square. 5 5s are 5 into 10 power minus 7 meter square. This is the final answer to this question. 5 into 10 power minus 7. What is the answer to this question? Area of cross section of the wire. 5 into 10 power minus 7 meter square.